Hi, good morning to one and all. Welcome to the today's session. Previous classes we discussed about the KP-KC relation and the applications of the equilibrium constant. Today we are going to discuss relation between equilibrium constant Kc, reaction quotient Qc, and standard free energy delta Z naught. Relation between equilibrium constant Kc, reaction coefficient Qc, and standard free energy delta Z naught. So before going to this topic, I have to say some fundamental about the thermodynamics. If delta Z is equal to positive, the forward reaction is spontaneous or feasible. The forward reaction is feasible. If delta Z is equal to negative, so delta Z is equal, so here delta G is equal to negative, delta G equal to positive. Sorry. Delta G is equal to negative, the forward reaction is spontaneous or feasible. And the delta G is equal to positive, the forward reaction is non-spontaneous or non-feasible. Delta G is equal to change in Gibbs free energy. Change in Gibbs free energy. Delta G value negative, change in the free energy. Delta Z is equal to final free energy minus initial free energy. Gi minus G initial. G of minus G initial. Delta G value is a negative, then the forward reaction is spontaneous or feasible. Delta G is equal to positive, the forward reaction is non-spontaneous or non-feasible. So here we can write forward reaction is non-feasible, means backward reaction or reverse reaction. Backward reaction is feasible. Backward reaction is feasible or spontaneous. What is meant by feasibility and spontaneity? Feasible reactions means commonly itself it is going without any external force or without any external energy. The reaction itself it is going. It is called the feasible reaction or spontaneous reaction. So simply we can say one example. Heat content move from high temperature region to the low temperature region. That is a spontaneous. Air move from high pressure region to the low pressure region. That is spontaneous. Water falls from upper level to the lower level. This is a feasible, spontaneous, without any external energy or without any external forces. the reactions itself it is going, that reactions are called the spontaneous reactions or feasible reactions. So feasible reactions and free energy relation, delta G value is negative, final value minus initial value will get the negative. The forward reaction is feasible. So reacting to products, for this delta forward reacting to product, that is called the forward reaction. So for this delta Z is negative, and if delta Z is equal to positive means this forward reaction is non-spontaneous or non-feasible, means it is a reversible reaction. So the backward reaction is feasible, or backward reaction is a spontaneous reaction. So all of this copy this and then go to the, based on the thermodynamic view and reversible reaction, we have one relation. That relation is equal to delta Z is equal to delta Z is equal to delta Z naught plus RT ln Q or QC. Delta Z is equal to delta Z naught plus RT ln QC. So we know QC expression for a general reaction. For a general reaction, A moles of A plus B moles of B gives C moles of C plus D moles of D, and QC expression is equal to concentration of C power C into D power D by A power A into B power B. B power B. This is the QC expression. If you write a QP expression for the same reaction, if you write a QP reaction quotient in terms of the partial pressure, QP is equal to partial pressure of C power C into partial pressure of D power D by partial pressure of A power A into partial pressure of B power B. So this reaction also we can write like this: delta Z is equal to delta Z naught plus RT ln QP. So QP or QC is called the reaction quotient, the concentrations of reaction at any stage, the partial pressure of the reactions at any stage. That is called the reaction quotient. Now, at equilibrium, we know at equilibrium, change in free energy is equal to 0, because rate of forward reaction is equal to the rate of backward reaction. The driving force of the forward reaction is equal to the driving force of the backward reaction. That's why there is no change in the free energy. This is called the change in the free energy. This is the standard free energy. Universal gas constant, absolute temperature, and natural logarithm, and the reaction quotient. So at equilibrium, change in free energy is equal to 0. That is delta Z is equal to 0. Reason is the driving force, the amount of energy is required to the forward reaction is called the driving force of the reaction for the forward reaction, and the driving force of the backward reaction, the energy is required to come back, that is a reverse reaction. Both are equal. Driving force of the forward reaction is equal to driving force of the backward reaction. So the change in the free energy is equal to 0, delta Z is equal to 0. At equilibrium, delta G is equal to 0, and QC, we know yesterday we discussed this topic, QC is equal to KC. At equilibrium, QC is equal to KC, and delta Z is equal to 0. Now if you substitute these two values, that is, let us assume it is equation 1, equation 2, and equation 3. So now equation 2 and equation 3 substituted in equation 1. In equation 1, so we get 0 is equal to delta Z naught plus RT ln Kc, RT ln Kc, because Qc value is equal to Kc value. This relation is a thermodynamic view of the reaction, relation between the free energy, standard free energy, and reaction quotient. Reaction quotient. Therefore, delta Z naught is equal to minus RT ln Kc. Delta Z naught is equal to minus RT ln Kc, or ln Kc is equal to minus delta Z naught by RT. We can write like this. This is move to the opposite side, ln Kc, and multiply with the minus sign here minus, you will get here positive, and ln Kc is equal to delta Z naught by RT. Now Kc, therefore Kc expression is equal to natural logarithm is move to the opposite side, we can get the exponential e power values, or take the anti-log on both sides. Take anti anti-log on both sides. Take anti-log on both sides. Then Kc is equal to e power minus delta Z naught by RT. Kc is equal to minus e power delta Z naught by RT. From this relation, we can say the reaction, is it possible, okay, feasible or non-feasible. So here the case number one, if delta Z naught is equal to negative, delta Z naught is equal to negative. Delta Z naught value negative means here negative into negative positive. Negative into negative is equal to positive. So got it up. So see here the delta already minus sign is there here. Delta Z naught I am taking the negative values, negative into minus plus, you will get e power positive value get. Therefore e power positive values you will get. E power positive. E power positive is equal to, e power positive values are greater than the 1. E power positive values is greater than the 1. Therefore Kc is greater than 1. Kc is greater than 1 means, what do you understand? Kc is equal to concentration of the products by concentration of the reactants. Concentration of the products by concentration of the reactants. Concentration of the products by concentration of the reactants. So it value is greater than 1 means more is the products and less is the reactant. One means reaction is, okay, now reaction is spontaneous, reaction is feasible. That's why more products are present and less reactants are present. Therefore forward reaction is feasible. Forward reaction is feasible. That is the case number 1. Next, case number 2. If delta Z naught values are positive values. Case number 2. Delta Z naught is equal to positive values. Delta Z naught is equal to positive values. So this is a fundamental equation, that is equation A, right? Kc is equal to e power minus delta Z naught by RT. So here positive values minus into plus minus e power minus values you will get. So delta Z naught equal positive values implies e power negative values. E power negative values implies e power negative is smaller than 1. E power negative values are smaller than 1. that implies Kc is smaller than 1. If our negative values are smaller than 1, Kc is smaller than 1 because Kc is equal, this is the expression, Kc is smaller than 1. What do you understand? Okay, now forward reaction is forward non-feasible. Forward reaction is non-feasible. So if Kc is less than 1, forward reaction is non-feasible. Means reverse reaction is feasible. Reverse reaction or backward reaction is feasible. Next, case number 3. Case number 3. Case number 3. If delta Z naught is equal to 0, delta Z naught is equal to 0 implies e power 0. E power 0 implies e values, e power 0 is equal to 1, that is equal to 1. Therefore, Kc is equal to 1. Kc is equal to 1. So, Kc is equal to 1 means, what do you understand? The concentration of the product is equal to concentration of the reaction we can take. So, the reaction attained the equilibrium. The reaction attained the equilibrium. Both forward and backward reactions are feasible. Both forward and backward reactions are feasible. Kc is equal to 1 means here in this case both are the feasible reactions. Both forward and backward reactions. Both forward and backward reactions are feasible. So these are the 3 cases and the relation between delta Z naught, QC and Kc. Right. Is it clear among girls? Is it clear to all? Is it clear to all girls?